In this video, we're going to work on the ALEKS problem called interpreting the skeletal structure of a neutral organic molecule. This problem is going to give us a molecule in line structure or skeletal structure. It's asking us to come up with a chemical formula for the molecule and also asking us to count up how many CH3, CH2, and CH groups are in the molecule. I think the first thing that we want to do is look at this line structure and either think about it or redraw it as a Lewis structure. That means we need to find the carbon atoms in the molecule and also any hydrogen atoms that haven't been drawn for us. Now we know that each one of these lines represents a bond that exists between carbon and maybe another carbon atom. So for example, this line right here, because we don't see any atomic symbols at the beginning or the ending of the line, we know that that means that that's a carbon-carbon bond. Same with this line right here, because there are no atomic symbols written here or here, we know that this is also a carbon-carbon bond, and I'm drawing dots to show where the carbon atoms are located. We've got another carbon atom here and here. This particular line right here, because we have an oxygen atom written at the end of the line, we know that this is a bond between carbon atom and this oxygen right here. It's a carbon-oxygen bond. So I'm going to redraw the molecule with these carbon atoms written in, the carbon atoms that we just found. I'm also going to write in the oxygen and the hydrogen that were provided for us. Now we also need to go through and find any hydrogen atoms that were not drawn in the line structure. We know that every single carbon atom likes to have a total of 4 bonds. Any carbon atom that doesn't have 4 bonds that are already drawn for us, that carbon atom has additional hydrogen atoms attached to it. So by that, I mean this carbon atom right here, we can only see one of its bonds, only one of them has been drawn, but we know that that carbon atom actually has a total of 4 bonds. Those additional 3 bonds are all bonds to hydrogen. This carbon atom, we can only see one of its bonds. That means it has 3 more bonds, and those bonds are to hydrogen atoms. This carbon atom has 1, 2, 3, 4 bonds. That means it does not have any more. There are no hydrogens on it. This carbon atom has 1, 2, 3, 4 bonds. Also, it does not have any more bonds. No hydrogen atoms here. This carbon atom, we can see one of its bonds. That means it's got 3 bonds that we can't see. Those are all of our hydrogens. What is the molecular formula? We need to count up 1, 2, 3, 4, 5 carbons. C5. Count up our oxygen atoms, or our hydrogens, we'll do that next. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C5, H10, and 1 oxygen. Now the last question asks us to count how many CH3, CH2, and CH groups we have. A CH3 is going to be a carbon that has 3 hydrogens bonded to it. I'm going to erase some of this highlighting here. So what we are looking for in this molecule is a carbon atom that has exactly 3 hydrogens bonded to it. And we have one right here. There's a carbon with 3 hydrogens. We have another one right here, and we have a third one right here. That's a total of 3 CH3s. CH2s, that would be a carbon atom with 2 hydrogens, and this molecule doesn't have any CH2s. The other carbon atoms that we have left, they don't have any hydrogens on them at all. So this has 0 CH2s, and then last but not least, a CH, that would be a carbon with only 1 hydrogen, and again, both of these are carbons with 0 hydrogens, so we have no CHs either.